of secret actually. Okay, to understand secret we actually need to see the problem. Okay, first, so what I'm going to do here, I have a deployment file over here. Let me search that. Hmm.
Can you please zoom it the screen?
Is it not visible? Okay, we can do one thing, we can create a file. mkdir, I'm creating a folder as, let me do one thing, let me increase the font size. Now it's fine.
Yeah.
I'm creating a directory grass1 and I'm creating a deployment over here guys. Okay, so I'm copying the deployment from some system, MySQL deployment Kubernetes. Just a second. Yeah, so let me do one thing. Let me start with MySQL. Okay, and we are going to create a deployment. So let me copy this data. Copy, paste. Done. Now. I want to create this inside a namespace which is called grass. Okay, so this is a very simple example of a deployment. We have already discussed this. Clear? Now see, whenever you want to run a MySQL container, you always need to give one environment variable, guys. Okay, that we have discussed in the Docker container also. Clear? So I'm using a version 5.6 of MySQL and giving an environment variable. And the value of that environment variable is, let's say I want to put a Red Hat. MySQL root password is what? Red Hat. Clear? Now. And let me run this file. kubectl create namespace grass kubectl create -f deployment.yaml. Okay, there is some error. What is the error? API version deployment metadata selector template labels containers environment variable name values. Okay, port should be here. Now it's fine. Done. One deployment has been created in grass namespace. That's pretty easy steps. Clear? Now what is the problem here? Let's say if you have given someone permission to view or to describe the resources inside this namespace. Okay. What that person will do, he will run this command kubectl describe deployment mysql and -n grass. See, the person is actually able to see the password, right? And I don't want that. I don't want someone to see my username and password. Okay. But over here, when you have created the deployment and when you have deployed the MySQL application, anyone who have access on this namespace can see this particular password, which is critical. Clear? And I don't want that. So to secure that thing, what we will do, we will store this information inside a secret. Okay. Now, we will create a secret. kubectl create secret. What is the name of the secret? Let's say I want to create a name of the secret with the name sensitive. Okay. Or MySQL secret. Okay. Hyphen from literal equal to, I can use a key value pair over here. Let's say I want to give a key as pass equal to, or for pass MySQL equal to, what is the password? Red Hat. And in which namespace you want to create it? In the grass namespace. And one more thing over here, you need to write generic. There are two types of secret. One is storing the normal key value pair, and one can store the files also. Like if you want to store some TLS certificates and keys. So I'm using a generic type of secret. Enter. So the secret has been created. Now, the key is pass MySQL and the value is Red Hat. Now, instead of directly writing the value over here, what I will do, I will use value from secret. Clear? And value from which? Secret. Key reference. And what is the key over here? You need to define the key, okay, which is pass MySQL. Name is, what is the name of secret? Secret name is MySQL secret. What is the key? Key is pass MySQL. Done. And in that particular key, you have stored the Red Hat value. Okay. So that will be actually passed to this environment variable automatically. So I'm not directly writing the value. I'm taking the value from a secret. And inside the secret, the data is actually encrypted into base 64. Now, pass MySQL is perfect. MySQL secret is perfect. Let me check once. MySQL secret, pass MySQL. Okay. kubectl get all -n grass kubectl delete deployment MySQL -n grass, and I'm again creating it. Create -f deployment, and I'm again describing it. Now see, can you see the password? No. So if any person is having some permission or a view permission on this namespace, he can only describe this resource. Now he can also describe the secret. kubectl describe secret MySQL secret -n grass. Still he will not be able to see the information. It is written as 6 bytes because Red Hat is having 6 characters. He is not able to actually see the password. But yeah, if you have given someone the permission to edit the resources inside this namespace, then he can run this command kubectl edit secret MySQL secret -n grass, and he can see the value. This is the password. Now this is the base in 64 encoded value. You can copy this and you can pass it into base64 decoder. And you can decode it. So the person will be able to see that the password is what? Red Hat. Clear? Secret always stores the information by encoding them into base64. Okay. So if anyone has an edit permission, then he can see the value. But if anyone is having the view permission, then he is not able to see the value, even if he is describing the secret or if he is describing the deployment. Got it? So this is how the secret works. Guys, so this is clear.
Kaushal, so this is the use case where all the changes on the particular application or container, not application, is a can you, sorry, Kaushal, what is exactly use case behind that for the secret?
How I have told you the use case. Now, if you are not using secret, anyone can describe your deployment and can see the information which is sensitive.
Okay.
Okay. कोई भी deployment को describe करके देख सकता है ना password क्या है root का.
Okay. Right.
But now he cannot see na.
Right.
Okay.
Right.
So that is practical of the secret. Clear?
Right.
Got it? Now.
Got it, Kaushal.
So you can use multiple secrets, you can create multiple secrets, you can attach them inside the deployment, multiple environment variables like this. 1, 2, 3, 4, 5. Value form. Let's say I want to give the user name, MySQL_user. I can create a different secret or the same secret for that, but in the secret, you can attach a different key value pair like user MySQL, like that. Okay, so it will automatically take the value. Okay, you can create different secrets also, and in a single secret also you can store multiple key value pairs. kubectl delete deployment kubectl delete secret MySQL secret -n grass. One more important thing is here. If you are creating a secret in this grass namespace, then that secret will only be used inside this namespace. You cannot use a secret of another namespace into some another namespace. Clear? Now, if I want to store multiple key value pairs, then I can create a secret with from literal -- from again literal equal to user MySQL equal to admin. That's it. Enter. kubectl describe secret MySQL secret -n grass. See, now 2 key value pairs are actually stored over here. Okay. So this is how it works. Got it, guys? Clear about the secret? Now, after that, if you want to store this information not in secret, then you can use config map. The command will be changed, config map. That's it. But what is the difference between the config map and the secret? If you are describing the config map, you can see the information. So config map does not encode the things and you can easily see them. But secret encode them and you cannot see them without edit permission. If you are describing a secret, you cannot see the information. But if you are describing the config map, you can see information. Okay. And how can you use this config map into a deployment? Very simple. Instead of writing value from secret, you can write config map key reference. That's it. This is the difference only. Otherwise, there is no difference. Everything is same. kubectl create -f deployment.yaml, kubectl describe deployment, and now see, set to the key this of config map instead of secret. Okay. So this is how you can use config map and secret. So if you want to store some sensitive information, then you can use secret. If you don't want to store some sensitive information, you can use config map. Guys, are you clear with the concept of config map and the secret?
What I understood from secret config file is basically you cannot want to share any sensitive information in the container, right, with anyone, right? Nobody
Yeah,
has been
in the namespace.
Namespace. Yes, there's namespace, right? So what is the in what is, who will use the config map in scenario?
Your voice is lagging, Manish.
Okay, let me rejoin again. Sorry, rejoin
No,
again.
now it's okay.
Okay, my question is that so in what scenario who will join this particular parameter config map scenario?
In what use case we will use config map?
Yes,
There is no such use case. You can directly give the value in the file also. Okay.
let in production we have 5 user, right, who's able to do work on the one single namespace, right? I'm just giving an example. 2 user have admin rights, so and 3 has a normal user, right? Read only. So read only is not a challenge, so we can use as a config map on that scenario, right?
Yeah, let's say you are having a namespace over here, and there are 3 users, Sachin, Kushal, and Rajat, and Sachin user is having the admin privileges on this project or namespace. Kushal is having the edit privileges, and Rajat is having the view privileges.
Correct.
Okay. Now, Sachin can run this command: kubectl edit anything.
Correct.
Kushal can run this command: kubectl edit anything. But Rajat can only run this command: kubectl get anything. Okay?
Right.
Because he has a view rule on this. Now, Sachin can see all the resources. Kushal also can see all the resources. They have the edit permission, no? If a Sachin user is creating a config map, Kushal user can access that. Okay?
Correct.
But let's say you have created a config map over here, CM. In that CM, you have stored the password user equal to Red Hat. Now, Rajat user can also see this information. Why? Because this is not encrypted. And Rajat user has the view permission, means he can describe the things, right?
Right.
Yeah. But if you are storing this information in a secret, then Rajat is not allowed.
Correct. Correct.
These Sachin and Kushal can see the information because they have the edit permission. Now they will edit the secret and they will see what is the base 64 encoded and they will decode it.
Fine. So okay. That is the
Clear?
now it's clear. Now it's clear. So what is the difference? If you want to show that information, anyone can view that, right? No, it's not depends on any what the rights he have. So on the but if the secret want to use the secret, then only that edit or admin or edit can see that, right?
Yes.
Okay, got it.
So this is all about the secret and the config map. Got it? Now, after that, we have to discuss about the Kubernetes installation, right? So it's very easy to install Kubernetes. Okay. So let me describe you. After that, you can install it. See what you actually need to do. You need to create 3 servers. Number 1. One will be master. One is node 1. One is node 2. You can have one node also. No issues. Now, after that, you need to create this repository on all the servers. Okay.
Can you please tell me what is the prerequisite from the hardware perspective? So if we required on the locally.
Prerequisite master 4 GB.
Okay.
Node is 2 GB. That's it.
That is fine. Okay. 2 GB is not for fine. Okay.
Okay. And 4 GB for master.
Okay.
After that, you can create this repository on all the servers. Okay.
Got it. Right.
After that, you need to install these 3 packages. One is kubelet, which is the agent. One is kubeadm, which is actually installation software. Kubeadm will help you to install the cluster automatically. Okay.
Okay.
And one is kubectl, which is the command line. Okay. Now, so yum install y kubelet kubeadm kubectl. Now, while you will run this command, it will always go for the latest version. If you don't want to install a latest version, then you can run this command like this. Kubelet or -1.18 star, kubeadm -1.18 star, and kubectl -1.18 star. Got it?
कुशल अभी कौन सा वर्जन है लेटेस्ट?
1.20 चल रहा है अभी. Maybe कल नया आ गया हो. I have not checked it. Yeah, 1.20 it is. Okay. Now, one more thing. If you want to install a version of Kubernetes on 1.18, then you need to install the version of Docker as 18 or 19. Okay. Don't go for version of Docker as 20. Clear? So run this docker-ce-18 start like that. Okay. So this is compatible with Kubernetes 1.18. If you are installing Docker latest, then it would not be compatible with this version. Okay. So remember that thing. It is not written on this documentation. After that, you need to enable the kubelet, start the kubelet, all set the host names of all the machines. Okay. And do entries in etc host file. So everyone can, or any machine can ping to each other with the name. Okay. Instead of IP. After that, you need to configure the firewall. One thing you can do if you are installing the cluster at first time, you can stop the firewall on all the servers. That would be a great approach. But in the production environment, you actually enable these port numbers. Okay, 64434 API server and different port numbers are there. Once this port has been allowed,
purpose, we should disable the firewall D, right?
If you are doing it first time, then you can disable the firewall D. Okay.
Okay.
In the production environment also, a lot of companies are not using OS level firewall. They are using the hardware level firewall. Okay, network firewall.
Right.
In that network firewall, you have to allow this port numbers. Okay.
Right.
Now, after that, you can update the IP table settings. Okay. So set this particular to 1 in the sysctl config file. So this ensures that the packet are properly processed by IP tables during filtering and port forwarding. So if you are actually stopping the firewall, then no need to do this step. Clear? This is very important. You need to disable the SLNX on all the nodes and make it actually permissive or make it disable. Okay. And after that, reboot the system first. Clear? Now, disable swap. you need to disable the swap on all the systems. Okay, and instead of running these two commands, you can also comment out the entry inside the etcf step file. Okay, that would be a great approach. So whenever you will reboot your worker nodes, swap will not be started automatically. Clear? Now, after that, you need to run kubeadm init pod network CIDR and this. That's it. And it is not required. Okay. Clear? You can ignore this setting also. So once you have run this command, the complete cluster will be installed, means the master will be ready. After that, you need to run these three commands, means you need to create a .cube directory.
Kaushal, can you go on the previous step number 1? So you are saying that we need to only run the sudo kubeadm init till only, right?
Yes.
Not the adding the specific CIDR, adding the, right?
It will automatically take actually.
Okay, ठीक है.
Okay. See, if you plan to use a different third-party provider, change the pod network CIDR value to match that provider's requirement. Okay.
Correct.
Now, after that, if you want to manage a cluster as a regular user, so you need to create a directory. You need to copy this admin.conf file into the home directory of user into .cube folder as config, and you need to change the permissions. After that, you need to set up the pod network. So kubectl apply -f. You can use Flannel. If you want to use Weave, then you can go to a link, Kubernetes Weave setup. This is the link. And this is the command. You just need to run this command. Okay. It will automatically set the Weave. If you want to go with Flannel, you can use it. After that, you can check the status of the cluster, kubectl get nodes, kubectl get pods --- all namespace. Now, after that, you need to join your worker nodes to the cluster. So you can run this command. Okay. And when actually this command will be finished, now kubeadm init, it will automatically print the join command. Okay. So you can copy from that and you can run this command on all the worker node inside your cluster. And your worker node will join your master. That's it. The cluster has been installed. So it's very easy. Okay.
Sure. We will try to do it.
Try to go with it. Just remember one thing. If you want to install the 1.18 version of kubelet, you need to go for the Docker C as 18. Okay.
Okay.
Or 19. By default, the latest version is 20. Do not go for 20.
Any specific reason? Can you just for information?
No, Kubernetes 1.20 is actually not supporting the earlier version of Docker. Okay.
Okay.
Yeah. So that's it. So the Kubernetes has been completed. Okay.
So
Now just give me a minute. Okay, I'm coming. Just give me a minute. Yes, guys. Now tell me, do you have any doubts on this topic? Hello.
Yes,
Audible, Kaushal.
Yeah. So Nagi Reddy, Ashish, are you clear with secret config map? You generally
yes,
don't
yes.
speak in the lecture.
Yes.
Only Manish and I talk.
Reddy, your voice is not coming. You are trying to speak.
No. I'm fine. Understood.
Okay, that's great. Okay, so I think we can start OpenShift now.
कुशल एक क्वेश्चन था जो kubectl init कॉन्फ़िगरेशन करते हैं वो CIDR यूज कर रहे थे उसके जगह अगर पैनल यूज कर रहे तो उसमें डिफरेंस क्या है?
नो फ्लैनल के लिए आपको वो CIDR दे रखा है. ओके
ओके अगर मुझे अगर बाय डिफॉल्ट यूज करना है तो वो यूज कर सकते हैं जो इनिशियल इंस्टॉलेशन में था वो.
yes, but if you want to directly set up the view, you actually do not need to give the pod CIDR. It will automatically take. Okay,
ओके
so no need to give that. Clear?
क्लियर.
Okay, guys, so that's all about the Kubernetes. Okay,
So we are start the OpenShift as a 4.5, right, or 4.6?
4.5.
Okay, 4.5. Okay.
Yes, guys. This is OpenShift, chapter number 1, describing Red Hat OpenShift container platform. Now, what exactly you understand with OpenShift? What do you think, guys? I want to hear from Nagi. Nagi, are you there?
Okay.
What
Yeah.
do you
Yeah.
think? What is OpenShift?
So as of like from the Kubernetes and Docker, like they merged into the one platform, and they added some of the more features on the Red Hat side. So they deployed into like they renamed as a OpenShift.
Okay, and what about you, Ashish?
OpenShift is a containerization software product developed by Red Hat, and it's same as open source from the Kubernetes as orchestrator for the Docker container managed by Kubernetes. Manage the Kubernetes.
Okay. Got it. And what you want to say, Manish, on this?
Kaushal, so what I learned from the last 2 weeks, OpenShift is a orchestration tool as a base of Kubernetes, but in OpenShift there is additional features providing by the Red Hat, like telemetry and one is more some other router services and some other services. Plus and OpenShift is using Podman instead of the Docker. What I learned in 2 weeks.
And now 4.5 is actually using Cryo.
Cryo is okay. Is for I think the same. I question asked the same to use Cryo is related to networking SDN something.
No.
Kind of Docker
Cryo is a
registry.
OCI platform. Okay.
It's like
Container
Docker
interface.
registry. It's
Okay,
like
okay, fine. Okay. Right. Yes. You told that it is a equivalent to Docker. Not now they are not using Docker. Okay.
Now see, what is the difference between Kubernetes and OpenShift? OpenShift is a great tool, okay, in the market. Now, why it is great? Let me tell you. Let's say, Manish, you are a developer. Okay. Now, and as you know, the developer only knows what? How to code. Developer is not aware about how to create Docker file, how to create images, how to upload these images to the Docker hub, how to run the Kubernetes commands, how to create deployment. The developer will not be aware about these things. Am I right?
Right. So
No.
developer is only work. He want to work on the application perspective only, right?
Yeah, he only is working on code.
Correct.
Now, once the developer has written the code, there is always a need of operation person who will actually create the image for him. So the operation person will write the Docker file. After that, he will create the image. After that, he will upload the image on the Docker hub. After that, in the deployment, he will actually give the path of that Docker image, okay, from the Docker hub. And Kubernetes will automatically download that image and Kubernetes will run the application, right?
Right.
So this is actually controlled by the operation person. Okay, now number one, what operation person will do? Create a Docker file. Number two, build it. Number three, push it to Docker registry. Number four, create a deployment file. And number five, create a resource. Okay, that's it. These all the things are done by an operation person. Now, I want to give a facility to a developer that he don't need an operation person. So what I have done, I have created OpenShift. Now, if my developer knows two things, how to code and number two, write a Docker file. And he has uploaded the Docker file on GitHub. After that, here you have the OpenShift. What OpenShift can do? OpenShift can automatically download that Docker file. Number two, OpenShift can automatically build the image from it. Number three, OpenShift can automatically push that image to an internal OpenShift registry, which comes pre-installed with OpenShift. Number four, OpenShift can automatically create a deployment. Number five, OpenShift can automatically create a service. Clear? And after that, number six, you can create a route and application is accessible now. Got it? Now this OpenShift gives you. Now developer only needs to learn what? How to write a Docker file. That's it. Once the developer is aware about how to write a Docker file, OpenShift will take care of everything from starting. Got it? That's why OpenShift is called what? Platform as a Service.
Service.
And Kubernetes is what? Containerization as a service. Are you clear with the difference?
Got it.
Yes.
Yes.
Now, after that, the developer has not uploaded the Docker file. The developer has uploaded the code only. In that code, he is having index.html. Okay, now. Number one, OpenShift can download the code 1.2. OpenShift can select a builder image for the code. Okay. And that builder image is having everything to run index.html. And 3, OpenShift can copy the code into builder image container. Okay. After that, OpenShift can create a new image. After that, OpenShift can push the image, create a deployment, create a service, create a route, and application is accessible now. And this feature is called what? S2I, source to image. This is also called what? S2I, source to image. Okay. And these builder images are created by Red Hat, which comes with support. You can also create a builder image for your environment. Clear? And you can pass it. Let's say the developer has decided to run a Java code. Now, every time developer needs to create an image, so what he will do? He will create a single image, and in that image, he will install everything to serve his code. Okay, this will be called as a builder image. Now, OpenShift will automatically take this code. OpenShift will automatically copy this code into the container which is created by the builder image. After that, OpenShift can automatically commit that to create a new image. After that, OpenShift can automatically push that image into internal OpenShift registry. And after that, it can create a deployment and everything by itself.
Sorry, Kaushal, nahi, upar se, nahi, it's not going well.
Tell me what doubt you have.
Till the pass and SAS के बाद नहीं कुछ समझ आया आपने. You have written 1.1.2 1.3, right? And then you said that this is all the things are S2I, source to image.
This is also S2I, source to image. Now, source can be a code also. Source can be a Docker file also.
My first doubt is that you said that this is PAS and whatever you write in 1, 2, 3, 4, 5, 6, 7, right? That OpenShift can download the code and then create a new image. OpenShift can automatically push the image, right? So you are saying, you are referring to that when we installing the OpenShift, that we have ready-made a lot of ready platform like PHP. Because I have seen that deployment as a OpenShift origin. So
a lot of builder images are already present.
Correct. So you are referring to that one, right?
But you can create your own builder image also.
So right. So you are now you are saying that builder image means if I want to learn, we can say that run my customized specific application on the top of normal CentOS. Okay, CentOS OS, right? Specific to telco application, whatever way you can say that, not the IT application. So that we called as a S2I or not?
No, S2I is a process to create an image from the source code or a Docker file. Got it?
Repeat the last line again. Come again.
S2I is a process to create an image from the source code or a Docker file.
Source code or Docker file.
Yes.
Which already available in the registry locally. Is it? We can say that
on GitHub.
On GitHub. Externally.
On GitHub, the code is available or the Docker file is available.
So that should be taken care. That should be taken care as a by the developer, right? Whatever we want to put, or we want to impend the code in the container or on the image, right?
Yes.
That I understand. That I clear now. So
see, you have three options. One is on GitHub, you are maintaining a Docker file. Okay.
Correct.
OpenShift will download that, will create an image from that Docker file, will push it and will run everything. Okay. Number two, you are maintaining the code on the GitHub. Okay. OpenShift will select the builder image by itself. Got it? Now that is not the production approach, obviously.
Second,
I will use a Red Hat builder image.
Second point is you want to say that the GitHub code is basically the application, whatever the application code use and it impend then the builder image, whatever we running on particular version, right?
Yeah. So let's say I have uploaded a PHP code. So OpenShift will automatically select a PHP builder image. And that PHP builder image is actually created by Red Hat. It has everything to run that PHP code. All the libraries, packages, everything.
This is the advantage. This is the advantage given by the OpenShift, right?
Yeah, but I don't think it is advantageous because see, if I'm using a Red Hat builder image, that builder image is having all the libraries dependencies. Maybe I do not need those libraries and dependencies. So unwantedly, this will always increase the size of my image, right?
Absolutely.
So I will create my builder image by myself.
Okay.
Number three, you are maintaining the code on GitHub. And you are also giving a builder image path to OpenShift. OpenShift will select that builder image and will create a container of that builder image and will copy the code. All the things you have to define in the script actually. Okay.
So
there are different type of processes.
Builder image should be placed on the my public Docker registry or
you can give the path. You can give the path.
Correct. Right. So I will put on the my local OpenShift registry and give the path and run the code. Correct.
Yeah. If it is available online, also it will download first. Obviously.
Right. In production, in normal scenario, in production, we have not any internet connectivity. Just download on some of the server and put it on the after copy into my cluster. Anyhow, some reason path.
Yeah.
Then I think the third is a best and production, which normally used in production, right?
Third is the best one.
Correct. Right. So this is the, I
How
think
you
in
can
Falco,
create builder images. Okay,
correct.
that is the tough part. Okay,
Yeah.
because you need to run the custom script, because how OpenShift will know that where to copy the code inside the container which is created from builder image, right?
I'm not like
OpenShift does not know anything that
right,
where to copy
yes,
the code inside the
correct,
container.
correct.
You have to tell everything. So for that you create a assemble, you create a run script. Okay, these type of things actually you need to prepare. Okay.
In case of third scenario or second scenario?
Third scenario.
Okay. So
In
I think
second scenario, it will automatically select a builder image by itself.
okay. So the third scenario, everything we need to give the input. There is no intelligence after selecting the customer, or
Once
we
the
can say the
builder
user.
image has been created and you have written the scripts of S2I, then OpenShift can do everything automatically. Okay. So you have to tell OpenShift, okay, that take the code. Number 2, create a container from this builder image. Number 3, copy the code at this location. These all the things you need to tell OpenShift.
Correct.
Okay.
Right,
After that,
right,
OpenShift will take care of everything. Once these
right.
steps are actually written by you, after that you can change the code anytime. So automatic will automatically use this builder image and will take the code and will create a new image, will push it and will create the deployment automatically. Got it?
Got it.
Yeah. Otherwise, it is not an artificial intelligence tool. So it cannot like automatically decide that
No,
where to
understand.
copy the code.
Understand.
Okay, so
So
you have to.
when we say that source to image, S2I is basically all three options are source to image, right?
Yes, all three options are source to image.
Okay, so okay.
Got it?
What are the okay? We now you describe the one option is a source to image, right?
This is the one difference. After that, there are a lot of difference.
Okay.
Kubernetes you install on a CentOS operating system, Ubuntu, any Linux distribution, right? If I talk about OpenShift 4.5, if you are using a full stack automation, okay, in that they are using RHEL Core OS. Now, what is the difference between this CentOS operating system and this RHEL Core OS? First difference is this RHEL Core OS is very lightweight. Okay. They have only implemented the things which are actually used by containers. Okay. But in a normal CentOS operating system, you have a lot of programs which are not necessary. Clear? This point is clear?
Correct.
Yes.
One more thing. When you update the operating system, it always updates by package, right? But this RHEL OS is updates by a single package. That's it. That is one more option over here. So you can anytime update your complete operating system as a single package. But when you are actually updating the CentOS, okay, normal CentOS, it is actually updated by package. 288 packages needs to be updated. 390 packages needs to be updated. It is not like that. And RHEL Core OS is having the support of Red Hat. Clear? So it is a lightweight operating system. Single package. One more thing, in the OpenShift 4.5, master must be running on RHEL Core OS. But you can use RHEL 7.6 on worker nodes. That is a possibility. Okay. But master will only run on RHEL Core OS. Got it? You do not have any option. You cannot run it on Ubuntu. You cannot run it on CentOS. Clear? Enterprise product. I'm talking about enterprise. Yeah. Now, so this is the first difference. Second difference, no S2I. And if you want S2I, you can configure Jenkins or a CI/CD pipeline. Okay. Here you have the S2I, which is a inbuilt CI/CD. Clear? Number 3. No ELK. ELK is pre-configured. Number 4. No Prometheus. Okay, everything you need to configure manually. Here, Prometheus is configured. Okay. Number 5, no internal registry. Okay. Here, internal OpenShift registry is pre-configured. Okay. So you can use it in a disconnected environment also. But in the Kubernetes, you have to configure the internal OpenShift registry by yourself. Number 6, it uses ingress, okay, which actually uses Nginx at backend. You can use HA proxy also, that is also a possibility. It uses route, which actually uses HA proxy. It is using a SDN as Multus. It is it is a customized thing. You can use Flannel, you can use Weave, etc. Okay. Number 8, installation. Is hard. Here, one-click installation. So there is an OpenShift installer, okay, provided the minimum requirement like AWS credentials and etc. It will automatically ready the complete cluster for you. Only a single click installation. Number 9, no great web console. Here, great web console. Even you can have SSH or you can manage complete OpenShift from only web console. 10th, it is not having the node high availability by default. You can configure that. It is having the node high availability by default. Okay. No, they do not have anything like cluster autoscaler by default. You can configure it. It is already having a cluster autoscaler. Okay. After that, it is a Kubernetes as a service and it is a platform as a service, and it works on top of Kubernetes and container engine. Okay, or you can say CRI-O. Got it? And it has open source. It is enterprise. These are the differences. Got it, guys?
Right.
Okay, I can upload this image onto Google.
Correct.
So these are the differences. Got it?
Got it, Kaushal. I think it's good. Start with that overview of that OpenShift and comparison with the Kubernetes.
Yeah, that's why people are actually loving OpenShift, because it is actually giving you everything. Okay.
But the money is asking by the Red Hat guys is very high.
That
Yeah,
is the
I know.
that is the first thing which a company is always thinking about.
And the
What
lot of
at the
and
end
the
of
lot
the
of
year, like
I have discussion with the Red Hat guys on the solution for the OpenShift. So they put it on a lot of prerequisite and a lot of things that is very challengeable for the any operator as well. So that I have seen. I will share this my learning or experience with that with you guys.
okay.
That's fine. So let's I think it's good. Can we wind up? So tomorrow.
Yeah,
Same.
we can wind up. Okay, we can do it tomorrow now. Okay,
Fine,
guys.
fine, fine.
Okay.